Hey guys, I got a question from a viewer, and I think it's a situation a lot of you guys might be in. So this guy said he wants to self-host a Jellyfin server at home. Pretty simple, right? He wants to share it with his friends and family, but he doesn't want to make them download and use any apps, including tunnel apps. Also, his ISP has him behind carrier-grade NAT on IPv4. So what can I do to help? So today I'm going to walk through all of the different hosting scenarios you have, how you can use a VPS relay or other services like that to self-host your services at home behind CGNAT. So come along on this adventure. So I'm AppleArt here, and I want to host something. Here are my friends. They have mobile phones. Maybe they have laptops, I don't know. They're trying to connect to my server. So here's my server. And all we have to connect with is the internet. So I have an ISP, they have an ISP, they connect to their ISP to the internet, I connect my ISP to the internet. How do we connect to each other? So in the old days, my router would get a publicly routable IPv4 address. I would then assign something like some private address to my server, and then I would port forward like that. So they would connect out directly to my router, and it would port forward me here. The problem, as I'm sure many of you are encountering in the real world, is that there just aren't enough public IPv4 addresses to give to every internet subscriber in the world. Not even close. The total IPv4 address space is like 4 billion, which is like half as many people as there are in the world. Some of it's carved out for different purposes. The Department of Defense owns a large portion of it that they're not using. Amazon owns a huge chunk of it. Servers need it too, in addition to just clients. So we just can't keep giving everyone an IPv4. So what has our ISP done? So the ISP's done in this case is their router gets a public IP, probably a group of them. Maybe they'll get, say, 256. And then behind that, they'll put a few thousand subscribers. So I'll have an address like 100.69.96.134. And so this is in the carrier-grade NAT space. So when I make a connection out to the internet, it masquerades my connection under the public address of the ISP CGNAT server, and then it goes out to the internet. And that works perfectly fine for connecting to the internet. But how do we connect back? Well, if someone tries to send a packet here, it'll look at it and say, who sent a packet out to that address and that port recently? Who do I match this connection up with? And if there's no connection to match it up with, it doesn't know where to send it. So it can't just say, well, we'll send everything here because they've got hundreds of other people to send it to as well. So we can't port forward anymore. And that's essentially the problem we're trying to solve here. So the rules for this video, we're going to try to self-host as much as possible. We can't rely on incoming IPv4 connections because we're behind carrier-grade NAT. We don't want to install any apps or tunnel apps on our friends' devices. So hypothetically, they could just go to a web browser, type in the address, and it should work. So here are all of the different options I came up with. I came up with this many options here. I'll fill in it later. And so from easiest to hardest, here's what we got going. So option 1. Now this is the only option I have today that completely does not rely on any external services. So we're not relying on any paid or free services. And that is to use IPv6. So I mentioned here that the ISP router has the public IPv4, and we get a private carrier-grade IPv4, and then our server has a private IPv4. So what if we transform this to v6? So now our ISP has something like, so they have some subnet of their own, but then they give us our own subnet. So they might give us like a /48 like this. And then we break that down into our server. Doesn't even matter what this address is. Doesn't have to be memorable. We just copy and paste that right up into DNS. So now that DNS name goes to this. Anyone on the internet that has v6 connects to our server. The end. Now, because IPv6 doesn't have NAT like v4 does, even if we have carrier-grade NAT, on the v6 side we can still accept incoming connections just fine. All we have to do is allow them through our firewall on our router. Now the dependence on this is that your friends have IPv6, which may not be true, and your application supports IPv6, which especially for games might not be true. For websites, you'll be just fine with IPv6 support. All the major web browsers and web servers are going to support v6. ISPs, it depends on what country you're in, how wide deployment is, but it won't be universal. So this is the easiest and smoothest option, and it just kind of gets worse from here. Now there are some big advantages to using v6 if you can do it. So first of all, we have no limitations on what ports we can accept. We're not limited to only web ports, not limited to high-numbered ports. We're not even limited to just one IP address. We can have as many as we want, effectively. So this should work for any application, granted that the binary has to support v6, but we're not tied to just being web here. Another thing that might be important if you're latency sensitive is we're not relaying through anyone else's servers. All the packets are going from our friends directly to us and back. There's no middleman in between. So this will be the lowest latency option of everything I'm going to show. So option 2, I'm only going to cover this one briefly because I don't have a tutorial for you guys, but that is to use a Cloudflare tunnel. Now these have a lot of caveats, but let's see basically how they work. So in our setup here, we got some stuff going on. So what if we bring in Cloudflare? So they're a pretty big company that does a lot of stuff. And we create a tunnel from our server out to them. So because we're reaching out, we go through the CGNAT and it's not a problem. Then they host our website in DNS, and our friends can reach out to Cloudflare to get to our website. Now there's some caveats here. So in the example, I have the cert here. So my TLS certificate is on my server. So if you use a Cloudflare tunnel and want people to be able to access it directly without also installing Cloudflare on their side, you have to put the cert up in Cloudflare. So Cloudflare has to do all of your TLS, and then this connection to the backend has to be HTTP, not HTTPS. So this is encrypted by the Cloudflare tunnel, then the backend does HTTP, Cloudflare does the TLS for us, and everyone can access it over TLS. So there's some pretty big deal breakers in this setup for me. The first one is that Cloudflare, at least for a free account, Cloudflare has to manage your domain name. So my domain name is not managed by Cloudflare, and I'm not going to transfer to Cloudflare just to make this demo for this video. But if you already have your domain in Cloudflare, then you can use their Zero Trust platform. You can create an account. You do have to give them your credit card, by the way. It is free. Then you can set up their tunnel. They'll manage TLS for you, which means you don't have the TLS cert on your end. So your side does not have a cert, which is not great. And so there's some complications here. This also means that because we gave Cloudflare our cert and we're doing HTTP to them, unless we get another cert issued for us, we can't do v6 directly either. All of our addresses have to go through Cloudflare. And actually, because of how they do DNS as well, we couldn't do that anyway. So the whole reason we're doing this whole dance is because we can't get IPv4 connections. But we could still get IPv6 connections directly. I guess they go the other way. They would go this way. So ideally, we could still let IPv6 go this way, and we just do this whole dance going through the cloud for IPv4. But since Cloudflare manages our DNS and our certs, they have to manage the whole thing. Now Cloudflare does have excellent IPv6 support, so your site will still be accessible over v6, but it won't be accessible directly. You'll still have to go through Cloudflare. And because of the way they use CNAME chaining and things like that, you can't just put in a quad A record that points to you and an A record that points to Cloudflare. It doesn't work that way. So that's a Cloudflare tunnel. I'm not going into detail on this, but I have a link up here to a video from Tom Lawrence if you want to watch that and how to set that up. Next up in my list of ways to get around CGNAT. This is a very simple tool called SNID. Basically the way this works is we do all the v6 hosting stuff we did in option 1. We set up our quad A records, they point to our server, our firewall allows it. So now people with v6 come directly to our server. So all we need to do is deal with the people that don't have v6. And that's what SNID does. It's a simple proxy that listens for TLS requests on port 443, reads the SNI out of them, does a quad A lookup, figures out where the origin is, and sends it there. It has some restrictions. We can force it to only work for certain domains and certain backend IP ranges, and so it only works for our own sites. But it's essentially very simple. All you have to do is set every single A record in your system to point to your VPS server, and when you set your quad A's up, they'll all work. You don't have to configure any of the backends or stuff like that. I've made a video before on using HAProxy to do this, and SNID is even easier. Now this does require you rent a VPS. There are some free offerings from Oracle, but I don't trust Oracle at all. So I've got a low-end VPS at Hetzner. We're going to try it out with that. So here's kind of how things are going. So we got our cert, we got our server, we bring in a VPS. So this is up in the cloud somewhere, and it has a public address, and it also has v6. And then our server down here also has v6. And so essentially what happens is if one of our friends makes a request and they support v6, they come directly here. So they just do an HTTPS straight here. If they don't, they get sent the A record to this server here, the 9 to 10, 11, and 12. And so their connection comes here. Then, so they say like, I want to connect to test.appleletter.net. So the VPS goes, looks up that domain name, figures out it maps to that, and then it proxies the layer 4 connection back to the origin, which in this case is over here. It's not intercepting the certificate. The certificate stays here. It's just translating from IPv4 to IPv6. And so that way, if our friends have v6, they take the direct path. If they don't, they go up through our VPS. So over on my blog, I have instructions on how to do this. We're using this tool called SNID. There's a blog post from the author on how it works, which is pretty cool. We're using the neat fact that IPv4 has a ton of addresses. So in this case, I have a VPS with Hetzner. They provide a routed /64 subnet. So that means the entire 64-bit address space gets sent to my server, whether I'm listening on that particular address or not. So by default, you listen on just : 1, the first address, but there are, I don't know, 64 bits of addresses left we could use. So basically, we're going to carve out a 32-bit chunk of this and put the entire IPv4 address space in there. So if someone does a request from 6.6.6.6, we encode that as the last 4 bytes of the IPv6 source address and use that as our source when we connect to the back end. So this way in the back end, you'll see a log that says it came from an IPv6 address. You'll know that it's the prefix of your SNI proxy, and the last 32 bits are the IPv4 address it came from. So we don't have to use proxy protocol. Our application doesn't have to support proxy protocol. It just has to support TLS. So we're getting a little bit broader here. We can support more than just HTTP, more than just HTTPS. We're limited to TLS. So that doesn't get us to games yet, but it gets us quite a few things. So following my own instructions, I need to download the binary from GitHub. So he has releases here. It's written in Golang, so we literally just need the binary. This whole file is a binary. So we'll copy that link, hop on over, we'll get that file. So now we have that file. I'm going to put it in user local bin and make it executable. So now when I run it, it gives me an error saying it needs to be configured, which makes sense. So I wrote a little systemd unit here. We can put that in systemd. Just call it snid.service. Paste that guy in. So not to replicate all of his docs, but basically I'm telling it to listen on only IPv4. So I'm assuming IPv6 will go direct. I'm using NAT64 mode. We need to have the 96-bit prefix that we're going to use to encode. And we need 1 or more IPv6 ranges to allow. So this backend CIDR, this is just valid IPv6 ranges that SNID will proxy to, because if we allow it to proxy the whole internet, people could figure this out, and we become an open web proxy, which is something we don't want to be. So essentially, if you do a connection to SNID, and the backend falls outside of this range, it just terminates the connection. One last thing we have to do is we have to route whatever we're using for our prefix. It has to get routed to LO. So I just added a line to the bottom of my Etsy network interfaces. So this is what my Etsy network interfaces look like. So I have the single IP from Hetzner, Hetzner's DNS servers. Their gateway is always FE80, and then I have a 96-bit route to link local. So for your benefit, I have a VM here that only has IPv4, no IPv6. So if we ask, so we have an A record that points to my VPS, and we have a quad A2, but we can't use it. We get a security alert, so we'll accept the risk and continue, and look at that, it works. So I know I've already made a video up here on using HAProxy to do this, but SNID is even easier, so this is going to be the method I'm going to use going forward, probably. Now, one of the advantages that HAProxy has over SNID is that there's a plugin for OpenSense to do this in OpenSense. So if someone wants to help me write a plugin for OpenSense to do SNID, it's a simple static Golang binary. It just needs like 4 options in the GUI. If any OpenSense devs out there can help me out, I can try to do it on my own, I guess. That'd be great. So advantages and disadvantages. So using SNID, this only works for traffic using TLS. Now TLS is more than just HTTPS, but it's not everything. So again, we're probably not going to get games here. But we do have more protocols than just HTTPS. We are also restricted to port 443 effectively because we've bound to port 443. That doesn't mean we can't use other ports. We could use different listen directives, for example, if we needed different ports. But that's how I've set this up. It still does require us to run IPv6 on our network. It does not require our viewers to run IPv6. And advantage-wise, if our viewers run IPv6, they'll get a direct connection to our house, and they won't have to go through the cloud. Whereas if they have v4, they go to SNID, sends them to v6, all's good. So this is a pretty low config approach. SNID pulls all of its config from DNS effectively, so we just have to set up the prefix ranges that we're allowing and let it go. So SNID is great for processing TLS connections, but what if we need TCP? Then we can turn to HAProxy. I've made a video up here on HAProxy before, and that's still a good video to watch. I still recommend it. So here I'm going to set up HAProxy to proxy TCP connections from IPv4 to IPv6, kind of like port forwarding. So we can use this for protocols such as SSH. So if you have a bunch of servers you want to access over SSH, you can expose them over IPv6 using public key authentication, which is secure, by the way. You will still get a bunch of randoms trying to log in with passwords, but it'll just get rejected right out. So then we can have our HAProxy server listen on a bunch of different port numbers and route each port number to a certain IP address on port 22. So let's set that up now. So this is our config again. So our user is going to connect out to our VPS, and instead of looking at the name they connected to, we're going to look at the port number. So we're going to have some table that says like, so depending on what port the connection comes in on, we decide what backend to go to. All the backends will put on port 22, the standard SSH port, and that'll go out to our origin. So once again on my blog post I have instructions here. You can even read my old blog post if you want to know more about how this works. But basically we're going to install HAProxy, and then I've got a bunch of configuration snippets we can choose from, so we'll take a look at those. Also important to mention, you can mix and match some of these techniques at once. So you could run SNID, for example, on port 443 to deal with your TLS traffic, and also run HAProxy on different ports as long as they don't use the same port number. So I have the config snippets from my previous example too, so if you just wanted to tell everyone on port 80 to F off and go to port 443, this will just send them back to where they came from, but with HTTPS instead. It's a pretty nice thing, so you don't have a bunch of HTTP traffic going on. Here we have HTTP and HTTPS TLS proxying. That's from my previous example. But SNID would do the same thing without the configuration. And then we have the layer 4 port forwarding. So here we set up a front end, we bind it to some port, and on the back end we give it the origin. So the port number can be different. The incoming can be v4 or v6, and the outgoing will be v6. So if you need to connect to your SSH servers remotely, we can do that. So in this case, I'm going to listen on 2222, and I'll type in the log address here. Also, with HAProxy's notation, we don't put a v6 address in square brackets, so we have to include all of the colons because the last colon on the end is the port. So just for fun, here's what's actually happening on that server. It's actually using Telnet. And it's going to play back for you Star Wars ASCII-mation, a classic from about 20 years ago. So just for fun, after this video comes up, You're welcome to telnet to my VPN server, vpnhell2.applr.net, server I've been using in this video. And I'll keep this ASCII art up for maybe a week or two. So have fun, enjoy it. So we're again in our system that only has v4 here. And this time I have to specify a port, so I'm on 2222. And there we go. So this method is essentially port forwarding from a v4 port on the VPS to a v6 origin, potentially on a different port. So this will work with anything that uses TCP. So this widens our horizons a bit. We're not limited to just TLS. We can do HTTP, Windows Remote Desktop if you're into that, SSH, Telnet like this example, those kinds of things. So a very useful config. So if you need more than just TCP proxying, maybe we need generic port forwarding. If we could take on our VPS and port forward from an IPv4 address and port that comes in to an IPv6 destination and port, that would be pretty handy, wouldn't it? Then we wouldn't be tied to TCP or even TLS. We could do TCP, UDP, ICMP ping, and pretty much anything else. So we're going to set that up with Tayga. So of course we got a diagram again. So I got my VPS doing its VPS thing, and I've got Tayga, which I've drawn as a separate box for a reason. So we have our friends that make a connection here, and they're on something like 9.10.11.12 colon port 666. So we need to send that here to 2001 DB8420, and hypothetically we'll also be on port 666. We could change the port, but we don't have to. So we need to get this translated from this IP import to this IP import. And Tayga does half of that, and Linux does the other half. So between these two guys, we have a special subnet that is IPv4 translated addresses. So I've used 192.168.233. So I can do 252 hosts with this example. And we also need a v6/96 to encapsulate the whole IPv4 address space again. So these guys talk to each other with their special little translation prefix. So over in Linux, it has a table that says incoming. So port 666 goes to, so it says when port 666 come in on our WAN, we port forward that to the internal address .233.5, port 666. Then Tayga has a separate table, map this IPv4 address to this IPv6 address. So essentially what we do is for every server we want to proxy, we give it a temporary IPv4 address in the translation subnet. And we put all those entries in Tayga. So Tayga has a long list. So Tayga has a list of all of the servers we want to port forward to, and it translates their v6 address to a v4 address. Then in Linux, we do a normal port forward, v4 to v4, to get them onto this translation network. Get the gist of it? Seem pretty good? Let's set it up. So again, I've put this on my website. Tayga, you can install it. I just wiped out the whole init.d script because it was old and crusty and wasn't systemd. And I also wiped out the example config file. So we'll just copy that and run it. So I deleted the old tayga.conf, and so here's my example configuration for this particular setup. So we're using NAT6.4 mode, so it's doing translation between 6 and 4. We need an address for Tayga itself, so I gave it address.2. Address.1 is going to end up being Linux, so .3 and on can be used for our internal pool. And then we also need a 96-bit prefix. This is going to encapsulate the whole IPv4 internet. So this is the prefix I got assigned for the VPS, so I just took :64 : out of that. We have plenty of space to work with. Tayga itself will actually take its IPv4 address and stick it in here, and that'll become its v6 address. So I wrote down here what that is. So that's C088E902. If you need to ping it, you can ping it there. And then here we got our map. So I just have two maps set up. So I've got two v6 hosts mapped to v4 in the temporary network. So let's copy this in. And I'll just change these maps to point to some real addresses that I actually want to work with. And then last up, I wrote a long systemd unit. So Tayga used to have an init.d script, which was kind of old and was really only used for NAT6.4 as like OpenSense does it, but this is a bit different how we're using it here. So there's quite a few things we set up here in the systemd script. So I'm slightly abusing systemd here, But when you have a systemd service, it has an executable that runs, that's the service. But you can also tell to execute something before you start, after you start, before you stop, and after you stop. And so I am using these lists of commands to add and remove firewall rules that correspond to this. So this is where I put my port forwards, this is where I set up the interface. So it's a lot easier than having like an init script or something that does all this work. I found it was easiest just to put it directly in the systemd script. One thing to remember if you're writing these rules is that you're not executing in a shell, you're just executing directly. So you can't do like environment variable substitution quite the same way. But you can just call bash as well if you want to, like I've done here. So let's see what my systemd unit looks like. So we have Tayga itself, so it's in user sbin, and we got its config file, and we put it in debug mode, which basically, because modern systems just log to the terminal, that's how we do it. And then I've got a number of different sections here. So at the very bottom, we need to enable routing. So I just echo 1 to these two sysconfigs. We also need to set up the NAT64 interface. So we're going to create an interface called NAT64. Tayga is going to create that when it starts. So after it starts, we set link up and we give it the address ranges. So these need to be the same address ranges you had earlier, but notice I gave it a .1 here and a .1 here. So Tayga got .2 and Tayga got another one on the same thing, but they're from the same subnet. So this is how Linux is going to talk to Tayga. And then here's where we add our IP table rules. I'm using port 23, that's telnet on TCP. And then after we stop, we remove that rule so that we clean up the rule table. This is just a DNAT rule, and we're going to destination of our translation subnet. So you can add a whole bunch of these if you want to port forward a bunch of things. Just make sure you have the add and the delete matched up. I think I used all real numbers in this one, which is easy for me. I really don't care if you know the v6 address of the server that I rented. It's probably going to be deleted in like a week or so anyway, so whatever. So next we got to do daemon reload and start it. So we can see all of our exec starts worked, and the service is running. So now I should be able to telnet from this system. So if I do like that, I should end up going through the v6 translation internally. And oh yeah, what do you know? So once again, we're on the no IPv6 system. And now I should be able to telnet into this guy. And it should port forward port 23 directly. There we go. So everything I've done so far assumes you can receive v6 at home, which if you have v6 from your ISP is probably true. But I'm aware that some ISPs are pretty bad with their IPv6 deployment. It's also possible your favorite VPS provider is DigitalOcean, and their IPv6 support is a crime against humanity. But in either case, what about a pure legacy IPv4 solution? So for this, I'm going to set up Wireguard. Since we can't receive connections through CGNAT, we can go out to the VPS with Wireguard and then send packets back. So essentially, I'm going to set up a Wireguard tunnel from my local router to the VPS. Then in the VPS, I'm going to port forward from the VPS to my internal network addresses. So let's set that up. Of course, again, I have a guide here, so we need to install Wireguard tools, which installs WG and WG quick. And then we're going to write a Wireguard conf. So whatever your router is, I'm going to configure the tunnel there first. We just need to configure both peers to have a private key and to have each other's public key. It's not all that hard, so I'm going to create an IPv4 subnet and do all that stuff. So it's my VPS relay. We'll generate a key pair. Listen on the standard port. Well, listen to 50. Yeah. So I'm using legacy addresses. So I can use a 31 subnet for this. It's not really a problem. And I'll create my peer in a little bit. So next up, I'm using the peer generator. This is going to generate me the start of a config file. We're going to edit it later, but the start of a config file. So this is going to be, so we'll generate a new key. There we go. And allowed IPs, I'm going to use a subnet that encapsulates my VPN subnet and also all of my home subnets. So this /16 encompasses the Wireguard subnet, but also all the other subnets I use at home. So there's one big route here. So this is the config it generated. So I'm going to call this Etsy Wireguard wg0.conf. I'm going to paste it in, and then back here I'm going to save. So I realize that my endpoint is actually different. It's actually home. So up in the interface section, I got some more to add. So in a WireGuard config, we can use these post up and post downs and pre-up and pre-downs. And so I'm going to use these to add IP tables NAT rules. So this is what my wg0.conf looks like. So I added listen port so we can listen and receive incoming connections. We are enabling IP forwarding so we can do routing. Down here we have 4 commands for each port forward. So 2 up and 2 down. So the down ones are the same as the up, but they have a -D instead of a -A, so delete instead of add. And so the first rule, we are saying if a packet comes in on either 0, then we change the destination to our internal address at home, so it goes over the tunnel and routes. So the other rule I have is a post routing rule, and that changes the source address to be equal to our tunnel address. That way, every time a packet gets sent across the tunnel, it is always going to come back here. Now this does, of course, mean we lose the source address doing this port forwarding, but that's a artifact of how the routing works. If we didn't lose the source address, we'd have to do some sort of conditional routing to get routes to go back to the VPS over the WireGuard tunnel instead of going out normally like they normally would. So IPv6 is better. Coming back over here, I also need to add the endpoint address and the endpoint port because they use the config generator. So in this case, it's VPN HAL2, and the port is 120. I'm also going to set a keep alive here to go through NAT, so we'll set that at, I don't know, 10 seconds. So now I can just say WireGuard quick up wg0. It should load the config and generate the interface. So I'm going to send a ping just to bring the tunnel up initially. So that's pretty good. We'll stop that. So now we need to allow traffic through the firewall. So I'm just going to initially say allow IPv4 any to any. Save that. So now can I telnet? This is obviously an internal IP, but can I tell it to it? Here we go. 20th century text. So finally, again, we're on the NoV6 VPN. We do telnet. And there we go. Our favorite movie. So upsides and downsides to this. Biggest upside is we don't have to move into the modern era and do v6. If you like all legacy, this one's for you. Downsides. So we're limited to doing one port forward. So we only have one public address to port forward from. This is how you end up with services using stupid port numbers. Every web service should be using port 443, but because we feel like we're running out of addresses in v4, we don't want to just give each service its own v6, we end up with like a bunch of random port numbers. But you end up with that in v4 no matter what you do. Another problem, because we're behind CGNAT, so the tunnel has to be established from our router out. But most of the connections are going to be coming in from the internet. So we need the router to continuously be doing keep alives to keep this session up. And once the tunnel's open, it has a keep alive interval set, so it will do that. But something has to trigger the connection to do a handshake from the local side. So you could do a ping, you could set up a gateway pinger or something like that, but something has to initiate this tunnel, and that's not automatic. So thanks for sticking around for this video. Hopefully you guys enjoyed it. How to do port forwarding, TLS forwarding, TCP forwarding, etc. from v4 to v6. My use case in this video was if you're behind CGNAT, you probably have public v6 but effectively private v4. This will help you get out to the whole internet. But you can also use any of these as an IPv4 to IPv6 transition mechanism. If you want to keep your whole data center IPv6 only, you can put these things at the edge where you're probably already doing load balancing, or maybe not. And this can help you as part of transition. That's what I've been using HAProxy for quite a while. I really like SNID, and I really hope that we can make that into an OpenSense plugin soon. I've also found some other interesting features of Tayga that I think would be nice to add to the OpenSense plugin as well. As a bonus, I have a guide on this blog post on my website. You can link down below for that. That has all of the instructions for SNID, HAProxy, Wireguard, Tayga. All of them are down there in my example configs. But I also have an example config for the ASCII-mation server. So many years ago, I found if you do telnet towel.blinkenlights.nl, you'll get to watch the entirety of Star Wars in ASCII, which is beautiful. and I wanted to see if I could host that because Telnet's a very simple protocol, and I could. So I found a server, but it didn't support IPv6, which was a bummer. So I patched it myself. It's written in Python. It wasn't that hard. And I was about to do a fork and a pull request and all that stuff, but then I realized someone had already made a fork and already done this exact same fix. And their fix was the exact same as mine. So just go download their fix from GitHub. It's pretty simple. Like I said earlier, I'm going to keep this server running for, I don't know, a week or two or something at vpn-hell2.applard.net. You just telnet there. You'll get to watch Star Wars. Hopefully you get to watch Star Wars. Maybe if you're on IPv4 you won't, I don't know. But yeah, so if you want to chat with me about anything else, if you have any other questions, Discord server link down below. I have a Ko-fi. This video wasn't sponsored by anyone, so I really appreciate donations from you guys. It cost me like €3 just for the VPS in this video, which isn't much, but I had to pay an extra €0.50 just for that IPv4 address. That's how much they cost now. So yeah, that's per month too. So thanks for coming along, and I'll see you guys on the next adventure.